This is Mrs. Benke, and these notes are on how to predict products in a chemical reaction when you are only given the reactants. Predicting products varies depending on what type of reaction you are dealing with. When we're dealing with a synthesis reaction, we want to look at the charges of the two elements that are the reactants. Gold is Au plus 3, and chlorine is Cl minus 1. When we crisscross these two elements, we end up with the formula AuCl3. Likewise, when we look at combining sodium and oxygen, we have to look at the charges of each element. Sodium has a plus 1 charge, while oxygen has a minus 2 charge. When we crisscross these two elements, we end up with the formula Na2L. Decomposition reactions are even easier than synthesis reactions because all we're doing is separating the two compounds, or the two elements that make up the compound. So in our example of barium chloride, it's going to decompose to barium plus chlorine. The only thing we need to pay attention to are those diatomic molecules that we spoke about: hydrogen, chlorine, iodine, fluorine, bromine, oxygen, and nitrogen. Whenever we have any of those elements, we need to remember to add a subscript of 2. Likewise, for calcium oxide, it will decompose into calcium and oxygen. And again, oxygen is a diatomic molecule, so we have to remember to add the 2. Single replacement reactions are the most complicated ones to predict products for, and that's because we have to use this reactivity series of metals. The rule is that the single element has to be higher or more reactive than the element in the compound that it's replacing. So if we take a look at our example here, our single element is silver. Silver is a metal, so it wants to replace the copper. If we look at our reactivity series of metals, we see that silver is less reactive than copper. Because of that, no reaction will occur. So we write no reaction. On the other hand, if we have copper trying to replace silver, we see that copper is more reactive than silver, so the reaction can occur. And what happens is that the copper kicks the silver out of its position. So now the silver is going to be by itself. That means the copper will be combining with the nitrate. Again, we have to take a look at the charges. Nitrate has a minus 1 charge, and copper has a plus 2 charge. When we crisscross these, we end up with the formula copper 2 nitrate, which is CuNO3 2. For a double replacement reaction, decide which elements you want to switch. Either switch the metals or switch the nonmetals. I like to switch the metals. So in my first problem here, I'm going to switch sodium and hydrogen. So sodium will come over to take hydrogen's place, and hydrogen will take sodium's place. Again, we have to look at what the charges are on all of our elements. So we're going to end up having hydrogen combining with sulfur, and we're going to have sodium combining with chloride. When we combine these elements, we end up with the formulas H2S plus NaCl. In our second example, we're going to be switching lithium with barium. So lithium takes barium's place, and barium takes lithium's place. When we write out our symbols, we have barium, which has a plus 2 charge, combining with sulfate, which has a minus 2 charge. And we have lithium, which has a plus 1 charge, combining with chloride, which has a minus 1 charge. So our final formulas are going to be BaSO4, or barium sulfate, plus LiCl, or lithium chloride. Now I want you to try to determine the products that will be formed in the 4 reactions shown below. Write these practice problems in your notes and either give your paper copy to Mrs. Benke or take a picture and upload them into Schoology.